Welcome to Your Math Explained, where we make math simple and clear. My name's Angela. In our last video, we looked at arithmetic sequences, which are lists of numbers that grow by a constant step. But what happens if you don't want to just list those numbers and you want to add them up? So imagine you get a new job where you make $100 on the first day, $105 on your second day, $110 on the third day, and so on. If you want to calculate exactly how much money you've banked after a full year, listing out 365 terms and then adding them up one by one is a nightmare. What you have there is called an arithmetic series, which is the sum of an arithmetic sequence. Today, we're going to use the genius trick discovered by a 10-year-old schoolboy to find the sum of any linear progression instantly. Now, before we jump in, if you haven't subscribed to the channel yet, make sure you do that first so you don't miss out on your weekly content. Back in the late 1700s, a young schoolboy named Carl Friedrich Gauss, who would grow up to be one of the greatest mathematicians ever, was being disruptive in class. As a punishment, his teacher told him to add up the numbers from 1 to 100. Now, the teacher thought that this would take hours, but Gauss solved it in seconds. He realized if you write the sequence forward and backward, a stunning pattern emerges. Now, what is that pattern exactly? Let's take a look. If we write down 1, 2, 3, 4, and so on, all the way up to 100. And then we're going to write the list again, but this time in descending order. So we start with 100, 99, 98, 97, all the way down to 1. And then we're just going to go ahead and add them vertically. So we go 1 plus 100. That gives us 101. And then we have 2 plus 99, which is again 101. And same thing if we go 3 plus 98, that is again 101. In fact, all of them are going to add up to 101. And there's going to be exactly 100 of them because our list is going from 1 to 100. So now if we want to add them all up, the shortcut is just 101 multiplied by 100. But realize that we've actually written the list twice. So therefore, we need to go ahead and divide this by 2 so that we get the sum of just one list. And this is exactly the logic behind this formula right over here. This is saying that if you take your first term, add it to your last term, and then we're going to multiply by how many terms there are in total, and then we're going to go ahead and divide it by 2. And that is going to give us the sum of the arithmetic series. Now this S sub n here stands for the sum of the first n terms. The second formula here you can use when you're not specifically given what your last term is. And to get this, all you need to do is substitute in the formula for u sub n that we went over in the previous video. So now let's take a look at how we can use this. We're asked to find the sum of the first 40 terms in the following series. So just like before, we're going to go ahead and write down all the information that we have. We know that the first term, u sub 1, is equal to 3. And then looking at the terms here, we can see that the common difference is 4. And we know how many terms we have in total because the question is asking us to find the sum of the first 40 terms. So n here is equal to 40. So now we're not given what S40 is. You can go ahead and calculate that first and then use the first formula if you want to. Or we can just roll them into one and use the second formula, which says S sub n is equal to n divided by 2 multiplied by 2 times u sub 1 plus, in bracket, we have n minus 1 and then multiplied by d. So now substituting in what we know, we are looking for S sub 40. So that's equal to 40 over 2 multiplied by 2 times 3 plus 40 minus 1 times 4. So we get this is equal to 20 times 6 plus 39 times 4. And that evaluates to 3,240. Now let's take a look at our next example, which gives us the sum of the series. So here it says the sum of a series is 1,435. And we know that the first term is 5 and the last term is 77. We're asked to find how many terms there are in the series. So we start by writing our u sub 1 is equal to 5. Our u sub n is equal to 77. And then we know that s sub n is equal to 1435. So because here we're given the last term, we can use our formula 1, which says s sub n is equal to n divided by 2 times u sub 1 plus u sub n. So now substituting in what we know, we have 1435 is equal to n over 2 multiplied by 5 plus 77, which means we get 1435 is equal to 41 times n, and then solving for n, we get n is equal to 35. So that means there are going to be 35 terms in total in that series. And now for our last example, we're told that an arithmetic series contains 20 terms. It has a common difference of -3, and if the total sum of the series is -190, it's asking us to find the value of the first term. So the information that we've been given is that n is equal to 20, s sub n, or sub 20, is equal to -190, and we know that the common difference d is equal to -3. So here we can see that we are not given the last term, and we're not asked to find the last term either. So therefore, we can go ahead and use our second formula, which says s sub n is equal to n over 2 multiplied by 2 times u sub 1 plus n minus 1 times d. So substituting in our values, we get -190 is equal to 20 over 2 times 2 times u sub 1 plus 20 minus 1 times -3. Simplifying this a bit gets us -190 is equal to 10 times 2 times u sub 1 minus 57, which means -19 is equal to 2 times u sub 1 minus 57. So therefore, u sub 1 is equal to 19. And now let's do a quick recap of what we covered in this video. We learned that an arithmetic series is just the total sum of an arithmetic sequence across a set number of steps. And we were given 2 formulas for it. You will use the first formula when you know the first and last term of the series, and you use the second formula when you know the common difference, but you don't know what the final term is. And all of this works because of the symmetry. When you pair numbers from the opposite ends of the series and add them up, it always ends up being equaling to the same number. And now it is your turn to give this a try. Can you find the solution to the problem on the screen here? Make sure to leave your answer in the comments below and let us know what other sequences and series topics you'd like to see in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.